Teaching and learning circuit prototyping is difficult for a variety of reasons, including that novice engineers' circuits tend to be big, stinking, wiry messes. To find a solution to this problem, we look to software engineering and the practice of coding styles. Examples of coding style include type indentation and naming conventions for variables and functions. Coding style can be thought of as good penmanship for coding. Evidence in the literature suggests that enforcing coding styles greatly improves readability of code and reduces errors. While many instructors agree that similar best practice behaviors exist for circuits and are important to learn, rarely are they taught in formal settings due to time and attention constraints placed upon the instructor. Inspired by this, we created CircuitStyle, a tutorial authoring platform and peripheral style behavior reinforcement system which allows an instructor to create and ambiently reinforce circuit-style behaviors for in-person workshop tutorials. The primary contributions of this work include a taxonomy of circuit-style behaviors aggregated from literature and interviews with electronics instructors, a web and mobile interface for tutorial complemented by an in-situ student monitoring tool for instructors, and a follow-along tutorial system for students that peripherally enforces circuit styles. We also deployed our system to a live makerspace-style workshop in order to evaluate if our system was effective at enforcing circuit-style behaviors. Let's see how it works. An instructor is first invited to log in and author their tutorial. They are greeted by a screen which allows them to upload a photo of their tutorial, as well as provide a description of what the tutorial will contain. Multiple photos may be uploaded in order to create a slideshow for the instructor to present. Once the photo has been uploaded, the instructor is taken to a screen containing the circuit-style behaviors. The instructor is allowed to edit any particular default style that is included with our system, or create their own circuit style. Each circuit-style behavior contains a name, details, severity level, method of reinforcement, and can upload a photo of good and bad examples of the style. There are two methods of reinforcement that our system supports: peer review and a quiz system. After the instructor is satisfied with their library of circuit styles, they are greeted by a screen which asks them to input a particular tutorial. After uploading the tutorial steps, the instructor is asked to assign which circuit styles they would like to evaluate at which step. Our system is also able to recommend which particular circuit styles might be suitable for a particular step. Once this is completed, the instructor is able to author subsections for their tutorial. This allows the instructor to guide the class through building and authoring in small modular sections in order to help mitigate errors, as well as test the class's understanding of circuit implementation orders, which we will cover later in the sorting step. Once the teacher has completed the authorship of their tutorial, the students begin by logging into the system on both the computer web app and their mobile phones. Students are then asked to sort the subsections of the given tutorial. This can be guided by the workshop instructor. This sorting step is meant to evaluate if students are familiar with proper implementation order for circuit prototyping. Once this is completed, students are brought to the main tutorial screen. The center screen contains an image of the current step of the tutorial, as well as the section name, step name, and detailed instructions on the step. On the top left-hand corner is a drop-down menu containing the style guide, which contains helpful and detailed information regarding the style which the instructor wished to enforce during this particular step of the tutorial. The menu is easily dismissed in order to ensure that the screen does not become too crowded for the student. If the instructor chose to evaluate a particular style using a quiz, the quiz will appear after a step in which that particular style occurred. At the end of a subsection, students will be asked to take a photo of their current circuit. This photo will be sent to other students, as well as the instructor, as part of the peer review process. During peer review, students are asked to evaluate the most recently uploaded photo of their fellow student's circuit, and evaluate if a particular circuit style is present. They can select yes, no, not sure, and leave comment feedback if they desire. This information is then transmitted back to the student as well as the instructor. During the workshop, the instructor also has access to an interface which will give them at-a-glance information regarding the performance and progress of the class through the tutorial. The right-hand column contains a collapsible menu which contains all of the steps and subsections authored in this tutorial. The steps are color-coded: gray for no students currently completing that step, red for a few students completing that step, and green for the majority of the students currently completing this step. The bottom of the screen contains pie charts, each one labeled with the name of a particular circuit style. The more green in the chart, the larger the class percentage adhering to that particular circuit style. The center screen contains the image of any particular step which the instructor wishes to see. By clicking the Style button, the instructor can have more individual information about the progress of their students. The screen contains the student's name, as well as a pie chart reflecting their individual adherence to particular stylistic behaviors. It also contains the student's most recent uploaded photo for peer review. The instructor is given access to a variety of different feedback mechanisms for directly intervening and interacting with the students through the system, including providing a quick thumbs up in order to provide positive reinforcement to the student. If a student does not perform well in peer review and they don't understand why, they can contact the instructor. When this happens, the instructor is provided with the most recent uploaded photograph of the student's circuit in order to contextualize the kind of problem they're experiencing. The instructor can either intervene physically or send a quick message through the system. For more information on our system, as well as the results of our user study, please see our paper.